Hi everybody, today we're going to go over input-output functions or t-tables. So here we have we're going to use these inputs, and remember the inputs are also the domain, they're also the x values, right? So the inputs are the domain and they're the x values. And we're going to put it into each of these machines. And so this is the rule of the machine. So for this rule, it says now remember the x is the input. So this rule says we're going to take whatever the input is. So we're going to take whatever the input is, and then we're going to square the input, and then we're going to add 2 to it. This rule says we're going to do like a -1 times the input plus 2. Right? So remember x is the input, and then this rule, sometimes they'll call it the equation, sometimes they'll call it the rule or the function. This one says we're going to take 1/3 times the input minus 2. So remember, x is your input. So let's go back and plug in -12. So we're going to say we're going to input -12 into the F machine. This is the name of the machine. And so when we plug in -12, that's going to go into the machine. So when -12 goes into the machine, that means we got to do -12 and then square it plus 2, right? So we're taking out, remember x is just a placeholder for the input. So -12 squared plus 2, and remember -12 times -12 is positive 144, and 144 plus 2 is 146. So 146 is coming out of the machine. So when -12 went into the machine, 146 came out of the machine, according to that rule. Now let's plug in -9. -9 squared plus 2, because it says the input squared plus 2, right? The input squared plus 2. So -9 times -9 is 81, and 81 plus 2 is 83. So that means, so again, when you plug in -9 into this machine, and then you take the input and square it and add 2, you get 83 comes out of the machine. So it's input, output, input, output. So let's see what happens when we plug in 0, when we put 3 in, and when we put 6 in. Okay, so take the input and square it and add 2 was the rule. So if we take the input and we square it and add 2, so 0 is going into the machine, 0 times 0 is 0, and then 0 plus 2, right? 0 plus 2, so 2 is going to come out of the machine. What if we put 3, take 3 and square it, plus 2, that's 3 times 3 is 9, plus 2, that would give you 11 out. So when you put 3 into the machine, then you get 11 out of the machine. So input, outputs. Remember the inputs are also the domain, and the outputs are also the range. And when you plug in 6, so if 6 goes into the machine, right, 6 squared plus 2 is 36 plus 2 gets you 38 coming out. So when you put 6 into the machine, 38 comes out. So 6 squared plus 2 is 36 plus 2 is 38. Okay, so the next rule is, so this one is function, so this is the G machine. And -x plus 2 is called the rule or the equation, right? That's the function rule. And if they want us to put in -12, -9, 0, 3, and 6. So if we input -12 into the machine, right, that's your input, that means we're going to replace the x. And remember, x is the input. So this means we're doing a -1 times the input plus 2, because remember your x is your input. So let's write that over here. So let's write -x plus 2 off to the side. So we've got the negative, and then x happens to be a -12 plus 2. So remember x is your input, so we put a parentheses where the x used to be. And don't forget, we still have a negative outside of that input, right? So we have a negative outside the input. So it's like the opposite of the input. So that's going to give us a positive 12. When you, right? Because a negative times a negative would be a positive 12, and 12 plus 2 is 14. So when you put a negative 12 into the machine, you're getting 14 out. Now they want us to plug in a negative 9. So remember, it's a negative and then negative 9 plus 2. Because the rule said we're going to replace the input with negative 9. But remember, there was a negative out in front of the input, right? There was a negative out in front of that input. So that means the opposite of negative 9, or a negative times a negative is a positive 9, and then 9 plus 2 is 11. So you get 11 out. And then you just keep doing input, output, right? Plug and chug, right? So we have a 0 or a negative, and then we're plugging 0 into the machine. So that's just going to be 2. So when you plug in 0, you get 2. Then they want you to plug in 3, so it's a negative and then 3 plus 2. Right? Negative 3 plus 2 is negative 1. So when you plug 3 into the machine, you get negative 1 out. Right? So it's just input, output. So it's just, the idea of that you're putting something into the machine. So we put 3 into the machine, and that gets replaced where the X is. And then negative 3 plus 2, it's going to spit a negative 1 out. So input, output. Right? And then the last one was to plug 6 in. So it's a negative times the input plus 2. So that's a negative 6 plus 2 would be a negative 4. Just watch your integer skills. And that's your input-output t-tables. And then the next one is an H machine. So this is the name of the machine, H machine. And we're going to put negative 12 into the machine. So remember what that means. When we're putting into that, that means we're taking, remember your X is your input. And so we're just going to take 1/3 times your input, subtract 2, and they wanted us to put negative 12. So I'll put the input in red. So negative 12 goes where the X used to be. So negative 12 goes where the X used to be. And then you have to do order of operations, which multiply first. So I'm running out of room, so that's going to give us negative 4, right? Because 3 goes into 12. Or negative 12 divided by 3 is negative 4 minus 2 is negative 6. So negative 6 would come out of the machine. So when you put negative 12 into the machine and do 1/3 times the input, subtract 2, you get negative 6 out. So input, output. I'm going to erase this because we're running out of room. And then they want us to put in negative 9. So now if we put in negative 9, that's going to be 1/3 times negative 9 minus 2, because the rule was 1/3 times the input minus 2 was the rule. And 1/3 of negative 9 is negative 3. So 3 divided by negative 9 is negative 3 minus 2. Remember, is plus the opposite. So that's going to give us a negative 5 out. And then they want us to plug in 0. So 1/3 times the input minus 2. So 0 times anything is 0. 0 minus 2 is, that'd be negative 2 out. And then if you plug in 3, so 1/3 times 3 minus 2. So 1/3 times 3, or 3 divided by 3 is 1. 1 minus 2 is negative 1. So when you put 3 into the machine, you get negative 1 out of the machine. And then the last one, we're plugging in 6. And when you do 1/3 times the input, subtract 2, 3 goes into 6 twice, 2 minus 2 is 0. So when you plug 6 into the machine, you got 0 out. So input, outputs. Now there is a fancy way of writing this. So you could write this function so that you wouldn't have to have the picture of the machine. So here we had a picture of a machine. So we could write this as, since this is the H machine, we could write H of X, that's how you read that, H of X equals 1/3 X minus 2. So this is another fancy way of writing it instead of having the picture. So this is saying that you're using the H machine. So this is the machine that you're using. And X refers to the input. And then this is the rule, right? This is the rule that you're using to get the output. So this is basically saying this is the output when you're plugging something into the machine, and we're saying it's plugging into the H machine, and then this is the rule that we're going to use, right? So we could write it like this, for an example. We could say H of 6 equals 0, meaning that we plug 6 into the H machine. So we plug 6 into the H machine and we got out of the machine 0. So this is a fancy way of saying this. These two mean the same thing. So this is the same thing as this. What's nice about this is it tells you what machine you're plugging it into. So for this point right here, we could say H of 3 equals -1. So that means when you plug 3 into the H machine, you're going to get -1 out. So this is just another fancy way of writing. Instead of a t-table, you could write this statement. It's the same thing. We wanted you to write a t-table though. So this is basically saying you're plugging 3 into the H machine. So this is your input, and you're plugging it into the H machine, and you're getting out a -1. So function notation, understanding the notation is important moving forward. Let's look at the next page. So just input, outputs, and understanding the notation. So once again, this time our function is p. So we could write this as p of x, meaning p, not p times x. So this is p of x is how you read this. It doesn't mean p times x. So the p is just telling you the type of machine that we're using. This is the Q machine. So this is just saying we're using the p machine, and then the rule of the p machine is -x. And then this is saying what you're plugging into the machine. So this is your input. So if we're going to plug a -12 into the machine, because that's what it's asking us to do, right? So -12 is going into the machine. So we could write P of -12, and then we're saying what do you get out when that happens. So notice the rule. This is the rule. So this is what we need. This is the mathematical rule. And so this says we're multiplying negative times, or -1 times the input. And the input happens to be -12. So negative times a negative, doesn't that come out to be a +12? So when you put -12 into the machine, you get 12 out. So again, the rule was -x was the rule. So it's negative, and then we put a parentheses where the x used to be. And then our input, what was going into the machine, I put in red. And then a negative times a negative gives you a +12 out. So it's just understanding the notation is what this is about. Like getting used to this, what we call function notation. Just another way to write it. So what happens if we plug in -9 into the machine? So if we plug -9 into the machine, so that means it's going to be negative and then -9. Right, because we're replacing the x with the input. And then a negative times a negative would make that +9 as the output. So when we put -9 into the machine, we got +9 out of the machine because we did a negative times the input. And the input was -9 for this part. And this is another way of writing this picture. What happens when you plug in 0? What happens when you plug in 3? What happens when you plug in 6? So isn't it negative? And then where the x used to be, that's your input. So it's negative and then 0 and then negative and then 3 and then negative and then 6. So we're just putting 0 into the machine. This is what's going into the machine. So that's called your input. And that's what the x means, your input. So a -0 is just 0. A -3 is just -3. A -6 is just -6. This machine is a different kind of machine. So this is a Q machine. So we could write the Q machine of, so Q of x is how you read that. So that's read Q of x is how you read that, is equal to -2. Right? So this is how you read this. Q of x. So you don't read it Q times x. So it doesn't mean multiply. It's a different style of notation. It's called what we call function notation. So you would think this would mean multiply because we've been training you this whole time that when you see a letter next to another letter or a parentheses, that normally means multiply. But in this context, the Q is not a variable. It's just the type of machine. right? It's just the function that we're using. So it's the function machine or the function. So this is the Q function versus the P function versus the X function or the F function or the H function that we had earlier. And we call this function notation. When you get into higher level math, we tend to work with a lot more than just one function. So if we're working with more than one function, we like to use the function notation instead of y equals negative x. Like I could have written this one as y equals negative x. I could have written this one as y equals negative 2. But when we're working with multiple functions, we like to name the function, and we like to use q of x equals negative 2. So different styles of writing the functions. And for right now, we're just practicing putting things into the machine. So a little weird, this is probably the first time you're seeing this function notation. So we just have to get used to the notation. So we're going to put negative 12 into the machine, right? Because that's what they asked us up here. They said to put in these. These were the inputs they wanted to plug in. So we're going to put negative 12 into the machine, but there's no x. So what do I do? Like before I had an x, and the x would come out, and in its place would be the input, right? So let's go back and look at the last one. We had an x, and so we took out the x, and where we took out the x and we put the inputs where the x used to be, right? We put all the inputs where that x used to be, but this one doesn't have an x. So what do you think that means if there's no x? So this is called a constant function. So this means no matter what you put into the machine, you're always going to get a negative 2 out. So no matter what you put into the machine, there's no x. That would mean negative 2 times x, right? If I put a plus sign, that would mean negative 2 plus x. But there is no x in this problem, right? There is no x in this problem. So you can't just make an x appear. If there's no x, there's no x. So we're not doing anything to the negative 12. So this is called a constant function. This is a constant function. This means, because there's no x, this means no matter what you plug into the machine, negative 2 is always going to come out. Negative 2 is always coming out of the machine, no matter whether you put a negative 9 in, a 0 in, no matter what you plug in going into the machine, negative 2 is always coming out, and that's called a constant function because it has no variable. So that means the q of x is equal to negative 2 is called a constant function. So even if I put a negative 9 in, there's no x, so negative 9 goes into the machine, and a negative 2 is going to come out. A 0 is going to go into the machine, and a negative 2 is going to come out. A 3 is going to go into the machine, and a negative 2 is going to come out. And 6 is going to go into the machine, and negative 2 is going to come out. Again, do you see that? Do you get that there's no x? So the fact that there's no x, that means just negative 2 is constantly coming out no matter what. So negative 2 is always going to come out no matter what because there is no x. And this is a constant function. Compare and contrast. If you go back and look at what we just did earlier, we had a function where it was, say, negative 3x. That means negative 3 times your input. But here there was no x, so whatever you plug in, you're getting negative 2 out. So that's your constant function. Okay, just input outputs and a little bit about function notation.